Yeah. Uh, is the screen visible?
Yeah.
So I will talk about how we can use partial dependence plots and individual conditional expectation plots for understanding what model has really learned. Uh, um, so what is basically partial dependence plot is here we try to see the relationship between some predictor variable and predicted variable that model has learned. So for the plot we are seeing here is on the data set where they were trying to predict manufacturer suggested retail price for the car on the basis of some predictor variables like horsepower or make of the uh, automobile, etc. So here they have plotted horsepower against a manufacturer suggested retail price. So as we can see, for the different values of horsepower, how the retail price is changing, how model predicted retail price is changing, that we can see through it. So basically, suppose the model has not learned it in right way. So for example, suppose now here it is going from say around 20,000 to say 1 lakh, but suppose it has gone from 1 lakh to 20,000, then we could easily say that this model is not learning what it should learn. So that is um, yeah. So how these partial dependence plots are plotted is like this. So suppose this is a training data, and uh, horsepower is a plot variable, and these are suppose different so basically we compute unique values of that, and others are the complementary variable, and we again compute different unique value for each complementary variable. And then for each unique value of the plot variable, uh, we generate a artificial data with different values of complementary variables. And then using the learned model, we predict for each instance, and then we get predicted manufacturer suggested retail price. uh, and then we compute for each unique value of the horsepower, we compute average of the predicted price, and then we plot that again, and that's how we get this partial dependence plot. So some of the examples like here, categorical variable make, we can see what model has how model is using the make of the automobile to predict its price. So for Acura make, the price is relatively high as compared to GMC make. Also, we can use this partial dependence plot for plotting the predicted variable against multiple predictor variables. So here they have plotted horsepower and origin of the automobile against the retail price. So through this we can uh, also get to know the relationship between two predictor variables. Other thing is we can also use this partial dependence plot for comparing the different models. So this plot was plotted on some basketball data set. and they were trying to predict what are the chances that player will make a shot. And one of the predictor variable was distance of the player to basket. So and they plotted these for three models. One is neural network, gradient boosting, and random forest. So as we can see, normally as the distance of the player increases, the chances of he doing the shot should drastically increase. So here, as we can see, random forest has learned that relationship better than other two models. After 28 or something, it has drastically decreased. Uh, so we have this PDP plotting function in sklearn as well, but it is somewhat the plots are somewhat different. So here, as we saw in the previous example, here we have predicted retail price. Um, so these are the average for each value of the different values of the horsepower. But in sklearn, when they plot, what they do is mm, so for each horsepower unique value, we are getting this average predicted price, and over this average predicted price, they compute a average, and then with respect to that average, they plot for each horsepower unique value. That is, so basically, for the different average predicted price, the mean is say around 1 lakh. Um, so that will be treated as zero, and others will be plotted with respect to that. So this is so this has the advantage that we can understand this plot in relation to the mean predicted price, mean average. So, uh, the next plot is individual conditional expectation plot. So there is very thin line between these two. The IC, what we do in IC plots is we select some observation randomly from the data, and for those observation, we try to see how for different values of predictor variable, how the predicted price is changing. So for example here, for a horsepower of 100, the predicted price for these selected observation is ranging from around say 10,000 to 30,000 maybe. But after 380 or something, for almost for all the instances, the price is predicted price is same. How these IC functions are computed is we again compute the unique values of the plot variable, and then suppose this is a selected observation, randomly selected observation. Then for different values of plot variable, we replicate the same observation, and then we try to predict for different values of horsepower the retail price, and then we plot the individual conditional expectation. Uh, so how it helps is in one of the case they observe that the partial dependence plot, when they plotted x1 and y1, partial dependence plot showed that there is no relationship in between, or model is not using x1 to predict y, or y is not changing much on the basis of x1. But if we see in the ICE, for one observation there is a positive relationship between x1 and y, and for another observation there is a negative relationship. So it's not like x1 is not at all impacting target variable.
Partial dependence is the partial dependence plot is basically averaging things out. So that's why you lose that
Yeah,
information,
that's
right?
why here, here we are seeing that there is no impact. Then there are these, so basically in IC, what we do is we select randomly some observations, and for them we do this plot. But we cannot have a lot of observations in the plot. That will make the plot difficult to understand. So what we can, so in order to incorporate many observations in the IC plot, what they do is they segment the observations. So basically cluster the observations, and then plot the cluster, consider the cluster as single observation, maybe taking the average values of the features, and then they plot this ICE plot. So basically here the blue line is consisting of some n number of observations from the data. So here what we can see is after when the distance to basket increases after 10, almost for all groups of observation, the chances are same. But when the distance is less than 10, some for some group the chances are relatively high as compared to other groups. This might be indicating that there is some other important predictor variable that is playing part for this group of data.
So what is being predicted on the y-axis here?
Whether the player will take a shot or not.
Whether the player will take shot. Okay. Okay.
Yeah. So PDP depicts how changes in input values affect the model predictions, and also helps to evaluate the competing models. Whereas IC also shows us interaction among model variables, and also helps to detect whether there are some unusual subgroups in the data. So for example, suppose here for one of the subgroup, only for one of the subgroups say chances are very less and other subgroups chances are very high, then we can say somehow that group of data is not something we should use, or that is not or that is something that we should look into why that data is like that.